Welcome back, Crammers, to question 14. A zip wire is shown as the dashed line AC in the diagram. The zip wire is supported by two vertical posts A, B, and C, D standing on the horizontal ground. The zip wire makes an angle X with the horizontal as shown in the diagram. The design of the zip wire requires angle X to be at least 5 degrees. Work out the least possible height of post AB, giving your answer to three significant figures. We can see that the shape is actually comprised of both a triangle and a rectangle. Since angle X is congruent to this angle, that means this is angle X as well. If X has to be at least 5 degrees, we can rewrite this as 5 degrees. BD at the bottom is 12 meters, so that means BD at the top also has to be 12 meters. And all we have to find is this distance, which we can write as y. Since we have two sides and one angle, we can use so, ka, toa. And since hypotenuse is not given, we cross out so and ka. We still have toa. So tan degree, which is 5, is equal to opposite, which is y, over adjacent, which is 12 meters. We multiply both sides by 12 to cancel out and isolate y. So y is equal to 12 tan 5. We can find this out using the calculator. 12 tan 5 is 1.05. So y is 1.05. But that is not our final answer since we have to find a to b. And a to b is comprised of y plus this distance, which is simply c to d plus cd. And since cd is given as 2.6, we can rewrite that as y is equal to 1.05 plus cd, which is 2.6. So AB is equal to 3.65, which is three significant figures. So our final answer is 3.65 meters. Thanks for watching. Cram, then scram.